Welcome back. In this video, I'll be walking you through first order differential equation part 3, which is one of the method of differential first order method differential equation, which is homogeneous differential equations. Now, the outline of this video, number one, we have number one definition of this method and the problems on this method. Once again, this is Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video, and also anytime you view, if you have not subscribed, help us to press our subscribe button. Subscribe, just help us to subscribe to it. You will see a subscribe button when you are viewing it. If you have not done that, please help us to do that. It's very important. Now in this video, I'll be walking you through these two things. And now please also, if you have any of our video, you want to watch any of our topic and that has parts, make sure you start from part 1 so that and if there is any problem, make sure you get back to us on message us, drop your email. We're going to be checked onto it. Now back to the real altitude. And I have first differential equation, which is homogeneous equation. Now if something is homogeneous equation, first OD, sorry, I'll be permitted to be using OD, which is ordinary differential equation. Do you get it now? As a first principle is what? Is mxy dx plus nxy dy are equals to 0. Now, if you have something like this, become a what? OD. Now, your m is attached to what? The x, and my n is attached to what? Dy. My n is attached to y and also attached to what? X. It means which may sometimes be written as dy dx equals to f of x y is said to be homogeneous. Said to be homogeneous if it can be expressed as y prime equals to what? G of what? X all over y is explicitly now, for example, e.g. now if I have, for example, let me write an example. I have something, this case, I have this case. Now I have this particular case. I have okay, y squared plus 2xy, all bracket of what? X minus x squared dy equals to 0. Now this is what I can say that what I can say that y plus 2xy squared equals to what? X squared dy. Now become an homogeneous equation if I have what? My dy dx equals to it will be equals to y plus 2xy divided by what? X squared. Now, which if I have this one, with the help of my fraction, I can say that this y squared plus what? 2y all over what? X. Now, if I can express any given differential equation this way, it means homogeneous equation is what? Is allowed. Homogeneous equation is allowed. Now, okay, let me also move on to another one. Okay, if I have another one this way, I have for instance, I have my problem this way. Homogeneous method. Now, homogeneous method of solution of ODE, that is ordinary differential equation. ODE, one way, okay, of ODE, one way of obtaining the solution to homogeneous is by setting y equals to v of x, and if my y equals to what, v of s, also my v can be equals to what, y all over x. Please take note of that. That is that. And also my s can be equals to what, my s can be equals to y all over v. Please take note of that. That is very, very important. Now, for instance, now if I have, and don't forget that if I have my y equals to v of x, it means my dy dx. This is an what? It's an implicit problem. I'll be having I'll be having x dv all over dx plus v dx all over dx, which I will have what? Which also will lead me to what? It will lead me to x dv all over dx plus v. That is mine. Very, very important. It means my dy dx is also equals to this. Now let me move on to example of this particular aspect of method. Now let me move on to example on this method. Now if I should have any example this way, okay, I'm on homogeneous. Its ways always occupy a lot of space when you are solving, but it's very interesting. Once you know it, it's very, very interesting. It's very, very, very interesting. Now, to me, like me now, as I'm solving it, it's very, very interesting. Now, if I have solve dy dx equals to 2x squared minus y squared divided by 2xy. Now, I'm to solve this particular problem. Now, how do I solve it? Solution, because I want to take a lot of space. Solution to this problem. Now, if I should solve it, the first thing I will have is what? Dy dx. Don't forget, I can have it as my prime, which is 2x minus y squared divided by 2xy. Now, if I have, just say that what? Let y equals to what? V of x. Now, it means my dy dx can be equals to what? V plus x dx dv, all over what? Dx. Now, that is very, very important. I hold on to it. I will differentiate this. Now, once I have that, I can now come here by having what? And I can say that what? My v, from here now, my v can be equals to what? Y all over x. From here, my v can be equals to y over x. Now, I can now say something like, I can say that what? Back to this particular equation, which is dy dx can be equals to, I can return all this to what? Now, wherever I see y, I will use this to represent x squared minus what? V of x squared divided by what? 2x v of x. Now, since I have this, it will now be what? What is my dy? This is my dy here. It means dy equals to what? Dy. Let me just say dy1 equals to what? dy2. dy2. It means I'll be having what? V plus what? X dv all over dx equals to, now what am I going to do here is that I can factor out what? X squared bracket of what? 2 minus what? V squared bracket of what? 2x squared and v. This will cancel out this. Since that can cancel out that, I can now say that what? I'll be having a problem this way, which is I will be having v plus x dv all over what the x equals to what 2 minus v squared divided by 2v. Now 2 minus v squared divided by what v squared. Now if I have this, I can answer my x dv the x equals to what 2 minus v squared divided by 2v minus what v. Now if I should use my normal fraction x dv divided by x dx equals to what 2 minus what v squared minus 2v squared divided by what 2v, which if I should do this and this, it will be what x dv all over what dx equals to this one will be what 2 minus v squared, yes, minus minus minus. Am I saying this? Am I making any mistake there? Okay. I'll be having something like this 3 and all over 2v. Now since I have something like this, I can answer that what my dv I consider my dv, I consider that what 2v divided by what 2 minus what 3v squared dv equals to what what's the name? I have x all over what dx. Now at this point I can easily run to my what integration, which is if I should integrate, I will integrate the both sides. Now if I should integrate this particular problem, it means that at the point of my integration, let me just m equals to what 2 minus 3v squared. Now if I should have the m equals to what, this one will be what minus 6v dv. Now it means my dv it will be equals to what minus what dm all over what all over 6v. Now I want to use substitution method. Now since I have this, I can now put this to this, which I'll be having now I'll be having integral of 2v divided by what m dot what dm all over what 6v. This will cancel this, equals to what ln x. Now we have done something like our ln. Check our integral method, you will see a lot of things there. Now since I have that, I can now move on by having this. I've covered this. Now if I should integrate this, if I should integrate the other part of this, I'll be having year 1 year 3. Now I'll be having 1 all over 3 and ln m equals to ln x plus what ln k. C rather. Now since I have this, what is my hem? This is my hem, which I'll be having 1 over 3 ln what's name? I have 2 minus what 3v squared. Absolute value is very good to have absolute value, equals to what absolute value of what ln of what x and what and c, absolute value. Now since I have this, I consider what my v. We know that our v is equals to what, my v is equals to, from here, this is my v. I can now, by moving by what 1 all over 3 ln 2 minus what 3, which is my x y squared all over what x squared bracket of equals to what ln what xc absolute value. Now since I have this, I can answer what my ln. If you are dealing with ln, as if you are dealing with normal logarithm, or if I have my ln of a particular, it means log of x of exponential. That is just the now it means my ln operates in base what exponential. That's just the logic behind it. Since I have this, I can now say that what my normal operation will now be 2 minus what 3y squared all over x squared all bracket of what 1 all over 3 equals to what ln what xc. Now this and ln, normally they are, as far as they are on the same base, they are equal to each other. It means I'll be having what 2 minus what 3y squared all over x squared equals to what? SC, equals to SC. Now, since I have that kind of problem, I can answer that what equals to SC. Since it's equals to SC, bracket of what? 1 all over 3. Now, if I multiply both sides by 3, this will cancel this. It means I'll be having 2 minus what? 3 all y. Sorry for my board. My board is not very okay. S cube, I can turn C cube can become A. C cube can become A. Since I have that, I can now do my normal things, which is I can decide to multiply all through by what? By s squared, which I'll be having s squared minus 3x cube equals to what? S is to the power 5 of A. It means my A can be equals to what? 2s squared, yes, minus what? 3y squared divided by what? S raised to the power 5, which is, that is my final. Sorry, before we jump into conclusion, there is a mistake I'm looking at here. There is a minus here. It means that minus will reflect across. Sorry, there is a minus, there is a minus, there is a minus, and also this will be minus, and this also will be minus. Sorry, the minus will be here. It means we are multiplying both sides by what? This also will be minus. Please, there will be a minus. Okay, let me try to elaborate this. There's a mistake here. Sorry, because that minus will cause a lot of issue. Now, since my minus is there, sorry, because the story will change, I'll be having 2 minus 3y squared all over x squared, all bracket of what? Minus 1 all over 3 equals to what? X. See? Now, I decide to multiply both power by what? By 3. Now, by having 2, 3y x squared all over x squared. Now, if I before I move on, if I should have 2x squared divided by what? X squared, all bracket of what? Minus 1 equals to what? S cube, and my a raised to the power 3 can be a. It's a constant. It means the number will change to another number. Now, since the number have changed, I can now say that what? Now, if I should make an inverse of, apply my principle of inverse here, I'll be having s cube all over what? 2x squared minus 3y squared equals to what? S3e. Now, since I have that, I can answer that what? I can multiply both sides by what? 1 all over what? S cube. 1 all over what? S cube. Sorry. Now, if I should do that, I multiply both power by what? It means this will cancel this. My a will be equals to what? Here will be 1. Sorry. Will be 1 here. This one will be cancelled. It means I'll be having 1 divided by what? 2x squared minus 1, 3y squared, all bracket of what? Of x, which are anyhow you want it. Or you can also say that what? My a bracket of 2x squared minus 3y squared equals to what? Equals to, of x equals to what? 1. Anyhow you want it to be. I think there won't be any. That's anyhow you want. That is how it is. Now let me give one more example. That is my final answer is what? Is this. That is my final answer. Now that is homogeneous equation. It's very interesting. Once you understand it, it looks very, very, very interesting. You just keep solving and solving and solving. So don't forget, I'm in part 3 of ODE. Now, if another problem is given to me, let me bring one more example. Okay. Okay. I have this is part 3, please. Part 3, very, very important. Now, if I have another question this way, that I'm having a problem this way. I have y squared minus 2xy, all bracket of what? The x minus s squared dy equals to 0. If I have this type of problem and I'm to solve this particular problem, now how do I achieve this? It means solution to this problem. How do I know that it's an homogeneous equation? Number 1, if my dy, I think my dy, the x. Okay, before I move on to, for learners, those that are learning, I can say that what my dy squared minus x squared minus can be equals to what dx y. Let me just make it y squared minus 2xy, or bracket of what x, which is minus. This minus will interact with this minus, they will cancel themselves. Now, since I have that, I can say that this one is not having square. The y, the x can be equals to what y squared minus 2xy divided by what x squared. Now, since I can have, since my dy dx can be equals to y squared all over x squared minus what 2y all over what all over x. Now it means it's allowed. Homogeneous equation is what is allowed. When is if it is allowed, therefore this step will be taken. My y equals to what v of x, and since my y is equals to v of x, now my my v, my the y, the x, it will be equals to what v plus what the x dv dx. Now, which that is very, very important. Since that is important, I can now say that what dy of 1 equals to what dy dx of what of 2. Now this is what of 1, this is of 2. Okay, this is of 1, this is of what of 2. Since that is allowed, I can now move on by having my what I can now move on by having my v plus what x dv dx equals to, and y squared all over x squared minus what 2x all over what x. Now since I have this, it means, and we're told that what my y is equals to what this, which is my v, my v can be equals to what y all over x. Now it means everywhere I'm having this, I'll be represented by what by v. It means my v is equals to this. Now I can have my v, my plus what x dv all over dx equals to what this one will now be what I'll be having v squared minus 2v. Now if I should use my normal, I'll be having x equals to what I'll be having v squared minus 2v minus what v. 2 squared minus 2v minus what v. Now if I should move on to this particular problem, okay, if I should move on with this, let me try to change the question so that I will be able to move on at time. Sorry, let me just make the question to be easy so that I will be able to work direct with what at time. I don't have that kind of time. Now if I have this, I'll be having x dv dx equals to what this, and this I'll be having v squared plus what v. Now I can now say that what my what I'll be having, this will be okay, I have x dv equals to what v squared plus what v, or bracket of what dx. Now since I have this, I can now change it by having my dv all over what v squared plus v plus plus v equals to I'll be having x d what all over dx. Now since I have this particular problem like this, it means I can now say that what partial fraction is allowed. Now at this point, partial fraction is what is allowed. That is why you have to watch our integration and differentiation very well before we understand this method of first order. Now which is I'll be having v plus 1 integral of what this one will now be what ln x plus what ln k. Now it's a constant. Now if I want to solve this thing, I will run through my partial fraction. Now if you do not understand partial fraction, please make sure you view and understand. Drop your comment after. Now if I should run through, I will be having b av plus what v v plus 1 equals to 1. Now, if I have that kind of things, I think you know that I will now make my a. It means my a will be 1, my a will be 1, and my what? My b will be 1. My a will be 1, my a will be 1, my b will be minus 1. Now, which I will now, and in partial fraction now, it will now be what? Integral of what? 1 all over what? What about what? V dv plus what? Minus integral of what? 1 all over what? V plus 1 dv. Now, if I should have this, sorry, I need to rub this side. That board is not enough for me. Now, I'm sorry for the question, I have to rub it up. It means once I have that, I can say what? Integral of what? 1 all over what? V dv minus integral of what? 1 all over what? V plus 1 dv equals to what? Ln sk. Now, ln sk. Now, it means this give me back to this. Now, if I should have this, I'll be having ln v minus ln v plus 1 equals to what? Ln what? Kx. Now, since I have this, ln kx, since I have this, I'll now be having what? Back to our normal logarithm laws, which I'll be having ln what? V all over what? V plus 1 of ln equals to what? Ln what? Xk. Now, absolute value is also needed. You have to introduce your absolute value. Now, since I have the same logarithm and the same, the log on the same base, it means this one and this one will reduce this one. Now, it means v plus 1 equals to what? Sk. Now, I can say that my k equals to what? My k equals to what? V all over what? S bracket of what? V plus 1. Now, I can now say that since I have that, what is my v? My v is given as what? My v is equals to what? Hence, my v is equals to what? Y all over x. My v is equals to, it means my k can be equals to what? Y all over x divided by x, we have a y all over x plus 1, which I can also relate it as k can be equals to y all over x. I have 1, now, which is going to be divided by x all over x bracket of what? Y plus x, which this will cancel this. Since that has cancelled that, I can answer that what? My k can be equals to sorry, this is very much. Now, my k can be equals to if I should run moving around, I'll be having y divided by, I'll be having x bracket of what? Y plus what? That is my solution. That is my what? That is my solution. Now, I'll be stopping here for this method. Now, before I stop, try this particular question and make sure you drop your comment. You should try to attempt this. Just try this. I have x squared minus what? Xy all bracket of the x plus x squared y equals to what? Equals to 0. Try this. Drop your comment after. Once again, this is Further Solutions Academy. Further Solutions Academy. Encourage us more. Help us to share our video, and anytime you have been and you have not subscribed, subscribe. Thanks for watching.